So we know how to find our median, but with that we also need to be able to describe spread with the inner quartile range. To do that we need to look at values that are called quartiles. So median is describing just the center of our data, and it's location based. Inner quartile range describes the distance covered by the middle 50% of values. So we're trying to get away from any that could be at the end of our data. So we do is we focus on just the middle 50% of the data. So that what we're imagining is we take our data and what we're going to do is cut it up into quarters. So that we have 25% of our data here, 25% of the data here, so on and so forth. What our inner quartile range does is it looks at how far does the data spread across that distance there. That distance will be our inner quartile range. So it gives out any lower and upper end values that could influence the distance that the data spreads, instead just focusing on that middle 50%. So what we'll need to do is figure out these numbers within our data that cut the data up in those quarters. Right here, here's our middle, so there's 50% to the right, 50% to the left, which means that's our median. What's new is this number here that kind of creates this lower 25%, that we call Q1. And Q1 is the first quartile. Then we have our median, and then this value over here that kind of cuts so that we have this upper 25%, that's Q3. So Q3 is our third quartile. And if you're wondering what Q2 is and why we skip over it, it's because Q2 is the median. We just always opt to say median and Q2. So in terms of finding these quartiles, the method's going to be pretty much the same as us finding the median. So going back to our data with the exam scores, let's find our median first. You always want to start with the median. So finding the middle value, we move towards the middle until we see there's our median. So this 82, there's our median. So we actually select that value of 82, so that's making our wall. So it's part of this wall here. So we can imagine is if we're looking at this lower 50% of, we want to cover up everything, including that 82 that was part of the median. So now just looking here, we want to find the middle of this data, which means with this lower 50%, go through the same method of finding the median. So that's 70 right there. That's our Q1. And then we do the same thing for Q3, where now, and still excluding that 2 there, go and find the middle, so that 94 would be Q3. So now we can see, like, if we look between, there's 3 data values there, 3 there, 3 there, 3 there. It makes this even disbursement of actual data values, without even taking into account the numeric numbers that are coming through. Like, it doesn't matter if that's a 31 right there, it's just placement-wise, we land at values there. So, the median is the middle, and we call it the 50th percentile. So percentile says percent to the left. Percentile is this idea of percentage of data to the left of that number. So if we're at the median, we'd have 50% of data to the left. If we're at the first quartile, then we have 25% of the data to the left. So this is our 25th percentile, 25%. Third quartile, we'd be landing out here, and 75% of the data is to the left. So what we want to do is create this thing called a 5-number summary. It's created with the minimum, Q1, median, Q3, and maximum. And we can even list it as a list of 5 numbers, and it's understood that that's the 5-number summary. So we calculated all of these. The only thing we're missing is the minimum and maximum. But for the minimum, just go and find the smallest value. So that's our 31. The median is 82. 94 is Q3. And then the maximum is 100. So you can write it out like this, or you can just list the numbers. And both are understood. These key 5 numbers, they're going to help us make something called a box plot, which we're going to do in the next video. These numbers, we found them by hand, which is fine. I'm going to attach videos for using technology because eventually we do just want technology to do it. If we plug in the numbers, just getting these values out from technology. But this is how we would do it by hand. For the inner quartile range, you take Q3 minus Q1, because again, we're trying to find this distance here. So you want to take this larger value minus this smaller value. So for us, we would take 94 minus 70, which is 24. And what this tells us is that the middle 50% of exam scores span 24 points in terms of on the exam. So there's this range of 24 points across that kind of main part of our exam scores. There's also something called the range, which takes the maximum minus the minimum. So this gives you an idea of how the complete data spans. So all exam scores span 69 points. However, as you can see, because we're still trying to avoid this outlier of 31, we don't want it influencing things. And if there's an outlier, it's going to be part of the calculation. So the interquartile range is a better form of spread than actual range. So rarely will I actually ask you for the range because the inner range is better.